Good morning, this is Dr. Turner for Integrated Math 3. Today we're getting into 9.4, which is looking at graphing trigonometric functions. We are focusing basically on just the primary three. We want to be able to identify, looking at a graph, what the function is, what are the properties of that function. Just again, the basics here. We're going to cover this a little bit in more detail next year. But let's go ahead and get started. I'm going to be using Desmos, but you want to be able to do this, by hand as well. A couple things, because we are talking about trig functions, typically rather than going by, a standard scale, and I'm going to adjust this here for my y-axis, let's say -5 to +5, so we're zoomed in a little bit. For your x-axis, rather than going by 1s or 2s, we're going to go by pi, because that's going to be more prevalent to our purposes. And specifically, I'm going to go by, let's say pi over 4. You can change it as necessary, but I'm going to go by pi over 4 here. So let's go ahead and get started. I'm going to also put this in radians rather than degrees, and I like the reverse contrast just so it's a little bit easier to see. So the first graph we're going to look at is sine x, or sine theta. So sine graph is an oscillating function. Oscillating means that it's going up and down, repeating. And if I were to zoom in or to zoom out, you can see that this graph goes on forever. However, there are some things that we notice about this graph. One is that it will always go between +1 and -1. Now, we've said this before when we first introduced the concept of sine and cosine, but sine and cosine, unless you're modifying the function, those values will always be between negative and +1, which makes sense there that the output on this graph, the y value, is also between -1 and +1. There are a couple things that we want to be familiar with. One is that when we look at the graph, we can notice that it is repeating itself. So we have sort of like this one iteration of the wave, and then after that, we could take that and copy paste it over and over and over again, right? Here's one iteration, here's another iteration, here's another iteration. So what one iteration, or how long it takes to go from one point to the other, we refer to that as wavelength. So here for sine, my wavelength is 2 pi. Okay. So it takes from 0 to 2 pi to complete one cycle of the wave. When you're looking at sine or cosine functions, you can calculate the wavelength going from any two points that are at the same location. So either from the start points, 0 to 2 pi, or I can go from two peaks, which would be pi over 2 to 5 pi over 2. Or I could go from two valleys, 3 pi over 2 to 7 pi over 2. Those all have the same distance, which is 2 pi. The other thing that is important to note about a sine function is that we have what's known as an amplitude. Amplitude is basically from the base, which in this case is 0, how far up and down is the wave going. And in this case, the amplitude is going to be 1. Because from 0, it goes as high as +1 and as low as -1. A common mistake on these types of problems is that students will say the amplitude is 2, but it is, from 0, from the center, how far up or how far down it's going. So the amplitude here is 1. Okay, that's your sine function. So you want to, from a graph, understand, what that is. The other important thing to note about a sine function is that points that are on the unit circle are also on this graph. So for instance, 0, 0, pi over 2, 1, pi, 0, 3 pi over 2, and 2 pi, 0. For more complex graphs, you're going to be expected to be able to sketch these based on values that are on the unit circle. So if I look here, I have, like we just did, when for sine, when I have 0, sine is 0. Sine of pi over 2 is 1. Sine of pi is 0. Sine of 3 pi over 2 is negative 1. And sine of 2 pi is 0. So knowing that, I could take those values on a piece of graph paper, sketch those points out, and then be able to sketch the curve going between them. Okay. We're going to have a similar process with the cosine function. Okay. Now, if you look at sine and cosine simultaneously, they look very similar. It looks like one is being shifted, and that's intentional. Okay, but with cosine, rather than starting at 0, or starting at the origin, we are starting at positive 1, and then repeating that wavelength. We can also get those values from the unit circle. Cosine at 0 is 1. And then going every pi over 2, we have 0, negative 1, 0, positive 1. And we can trace those values looking at the circle. 0, pi over 2, pi, 3 pi over 2, 2 pi, and we could plot those on a piece of graph paper and sketch that. Cosine, just like sine, has a wavelength of 2 pi, also has an amplitude of 1, which you want to be familiar with. Okay. So sine and cosine are pretty similar. When we look at tangent, however, tangent does not look like that. Right? It does not look like that repeating function. Now we still have repetition. If we were to take one of these curved lines, let's say between pi over 2 and 3 pi over 2, I could take this graph and copy and paste it over and over and over again. Now, looking at the unit circle directly, all we said was that x is cosine and y is sine. We don't have a value for tangent on the unit circle directly, but we could find tangent by doing sine divided by cosine. So for instance, the tangent of 0, if I do 0 divided by 1, that gives me a value of 0. And so if I look back at my tangent graph, sure enough, I have, for tangent of 0, I have a value at 0. However, it looks like this graph is continuing to increase and then decrease at given values. If you'll recall, these are what are known as asymptotes. So when I have, let's say, a value at pi over 2, that creates an asymptote because I don't have a tangent value at pi over 2. If I were to type that in my calculator, I would get something that says undefined. And we can see that from the unit circle. If I were to take sine over cosine at pi over 2, I'd be trying to do 1 divided by 0, which is impossible. So your tangent graph has an asymptote at every pi over 2, and this is how we notate it. We're going to say there are asymptotes at every pi over 2 plus k pi. So at pi over 2, at 3 pi over 2, at 5 pi over 2, etc., where k is an integer. So it could be a positive integer, it could be a negative integer, because going the other way, I also have asymptotes at negative pi over 2 and negative 3 pi over 2, etc. So your tangent graph is a little bit different. You want to be familiar with that, where your asymptotes are on your tangent graph. And if you were sketching this on a piece of graph paper, you'd be expected to be able to sketch out the asymptotes as well. Tangent graphs don't have an amplitude, right? Because the wave is technically going all the way down to negative infinity and all the way to positive infinity. But it does have a period. Remember, period is basically how long do I have to look at the graph to be able to copy and paste, if you will. And so unlike sine and cosine, which have a period of 2 pi, your tangent function has a period of just pi. So every pi, I'm copying and pasting that graph. That's it for 9.4. If you guys have any questions, please reach out to me. Otherwise, have a good day, and I will talk to you soon. Bye.